As just said, I'm Dion McMurtrie. I'm from the Australian Digital Health Agency. And I'm here to talk to you about the National Clinical Terminology Service, and I guess somewhat cheekily to see whether anyone's paying attention and out of my own curiosity, who here has heard of the National Clinical Terminology Service? Raise your hand if you've heard of it. Okay, interesting. All right. Well, hopefully you'll come away with a good idea if you haven't heard of it already. So the agenda for today, that what I was interested in going through was first to talk a little bit about what digital health is and what terminology is in terms of digital health, to understand why terminology is important. I'll go through a little bit about what the NCTs is for people who are uninitiated, and then talk a bit about the current evolution of the NCTs and then the future evolution that's sort of in the pipeline at the moment and why we're doing that. So first, taking on digital health and terminology. So digital health, hopefully we all kind of know what digital health is and why it's important. The previous speakers, what they were talking about in particularly having improved healthcare outcomes and better health delivery is really what it's all about by sharing data. And I think terminology is the key part of really sharing the meaning behind that data so that we can get to true semantic interoperability. And obviously just sharing information so that one human can see what another human can see is useful. However, if we really want to get to that level of what the last two speakers were talking about in predictive and preventative medicine, even personalised medicine, we really need to be able to exchange data that machines can understand to a really deep level and provide really powerful analytics. So that's what terminology is all about. We've got information model structures like FHIR, we talked about before, CDA, those sorts of technologies, sort of the containers, and twinned with them is the terminology which provides the meaning of the data within it, and together those two parts really are the key to interoperability and being able to provide that platform of shared data that can be used to enable all those powerful use cases that we've been talking about.
Joe thinks he has a common cold.
So I'll lead on with this.
Joe goes to see Dr. Jill, who enters his diagnosis into the system. Actually, Joe has a chest infection. Achoo! Achoo! So Jill asks Joe to see Jack the pharmacist, who accesses the system and can give Joe his prescription. But GPs use many different practice management systems, and pharmacists also use many different pharmacy management systems. And of course, they all speak a different language, don't they? Healthcare professionals can use SNOMED, an awesome international clinical terminology standard that can sit within their systems to talk to one another. It's like a database of common medical language. But SNOMED doesn't update automatically, and Jill and Jack have to wait for the system vendor to manually install new updates. Highly manual, complex, and inefficient. So, the Australian Digital Health Agency launched the National Clinical Terminology Service, NCTs, and with CSIRO, built some clever state-of-the-art technology to solve the problem. The NCTs is a cloud-based software as a service. It provides access to an authoritative source of content, the National Clinical Terminologies. It has fast, accurate search algorithms and enables automated distribution of content, so it's always up to date. Whoa, hang on a minute, says Joe. What does all that mean? Well, Joe, says Jill, because there is an up-to-date standardised coded language, your clinical information is accurately captured and understood by all other systems and healthcare professionals you may visit. Hey, that's hot, says Joe.
So that's a pretty naughty little video, but it's what it's really trying to tell the story of is that without us being able to keep that terminology up to date and to use consistent terminology across these systems, our ability to be able to use the data that comes from those systems is somewhat limited. And even if the implementation of those systems isn't that great, it can skew the data and can cause all sorts of problems with us trying to accurately use that data for those benefits we're looking for. So, why did we create the NCTs? Essentially, this is the problem. We started out before the NCTs, like many other national release centres, for primarily SNOMED-CT, but other national coding systems, with a complex set of data, being SNOMED-CT, that was delivered as a big data package and a really big manual that went along with it, and an expectation that the vendors would just sort of figure that out and implement it okay. And of course, that doesn't really work so well. There's a lot of variability in implementations, and as I mentioned, the quality of that variability can really impact what the user experience of the clinicians, and therefore the data that gets recorded itself. And obviously cause a lot of frustration for clinicians, and ultimately rejection of systems, which is a big problem. And then ultimately sorry. Yep. Not sure what happened there, but so the other issue is that, as mentioned in that video, there's actually slow update cycles, and we end up with systems running different versions of the terminologies. That's okay, the terminologies are built to work that way. However, the greater those variations are, the worse that problem becomes for the interoperability. And then the other problem that the vendors are facing is that they've got data coming from lots of sources. So we were distributing SNOMED-CT, but you need way more than just SNOMED-CT to be able to operate in the health system. There's obviously data like PBS and MBS. There's a bunch of different Australian Bureau of Statistics data sets, and they're coming from all different places, all different formats, all different times, and it's very complex and frustrating for the vendors, and ultimately very frustrating for the clinicians as well. So the NCTs, this is essentially a really simple example or a simple diagram of the solution. We aimed first to sort of centralise the content, so to become a one-stop shop for all of this content, so that the vendors didn't have to look to lots of different places to get it. The main aim to this is to also provide APIs and services that codify all of the rules in the big complex documents that we have that people like me and my team understand, but we don't need to teach every vendor the intricacies of all of the terminology, and we can wrap that into services for them. That makes life easier for them, but it also means that they get easier path to better quality solutions. And then we also provided automated updates for them to be able to update content much more quickly and easily. And I guess the main thing is that vendors can actually integrate into the NCTs here, where they've got all of those endpoints. But they can also run their own version of the software, the terminology server, and mentioned in that video was CSIRO. It's the Australian Health Research Centre's product called OntoServer that we're using. And they can run their own version of OntoServer for free, syndicate that content into it out of the national service whenever they want. It's a pool-based model, and that makes things an awful lot simpler. So here's a quote. Graham Grieve, the fire product director at the time, said that with the NCTs, they can leave the hard stuff to the specialists and just focus on making their applications work well with terminology, speaking of vendors. And that's exactly what we're looking for. We're trying to take away a burdensome problem that the vendors aren't trying to compete on, and deliver better solutions as a result. So the NCTs is a website, but it's more than a website. The most important part of it really is the services it provides. And so there's fire terminology services endpoint, which vendors can run for themselves if they wish to. There's free licenses, obviously, to run that software for themselves for use in Australian healthcare, as a deal we've done with CSIRO. And there's a W3C Atom-based syndication protocol, and it's all based on OAuth 2 and Smart on Fire. So we've really gone for, as much as we can, international standards where possible, rather than rolling our own versions of all of these things. The obligatory graph that shows the uptake of the service over time. We're up to about a bit over 1,000 licensees for the application, or for the platform to get the data. When you consider this is clinical terminology data, that's just in Australia, that's actually a fairly large number, because a lot of these are organisational licences. And then you can see OntoServer licences up to about 60 or so. healthy representation of vendors taking up that service. And again, when you consider an organisational licence, there is like Queensland Health or Telstra Health. There's actually quite a very large number of instances getting around. So the original NCTS build. So the current NCTS implementation, so it's all AWS based, and I thought I'd sort of take you through how the original build was done and what it looks like now, mostly because we're here to talk about AWS. So the existing implementation was actually built directly into AWS rather than building it out on our own tin. That decision was made and it was built out when we were actually still the National Health Transition Authority prior to the Digital Health Agency. However, the application was really built as I suppose, a traditional application at that time, a microservice-based application built not necessarily using deep cloud platform services, but really just using AWS as infrastructure as a service. So based on Docker, running on EC2 instances, and quite a lot of infrastructure as code deployment using CloudFormation, OpsWorks, Chef. And ultimately all of the deployment and build is done outside of AWS on our own infrastructure using Atlassian suites. So this gives you a very, very high level view of the application as it was built. So as you can see, it's very much an infrastructure as a service application. The only real sort of platform sort of services, load balancers, all of the infrastructure. However, ultimately everything is really run as a Docker container inside EC2 instances. RDS is used, and then there's an awful lot of complexity in this box down here, which is how those services, those individual services, are orchestrated into AWS and configured and operated. So NCTS 2.0 is sort of what we're working on right now. The reasons for those changes really simplification, cost, risk. So the current system, it may not look it, is actually quite complicated in operation because there's a number of different services that are operating configured together and glued together with the deployment process. All of the cost of operating that means there's a bunch of permanently on services, which are obviously costing more money than they would be if we were using it per transaction. But there's also a fairly high operating cost for our staff to feed and water the system, particularly in the area of security, where when we rebuild and patch and manage the versions of all of the software running, operating systems, etc., it's fairly heavy-handed. The design originally was built out as high availability, and some of that's been pared back based on cost versus need. But it's not really intrinsic in the design, the high availability of this system. And ultimately, we're being pressed for more services, and particularly FireR4 is probably the biggest thing going on at the moment, but there's lots of different services we could be adding. But we spend a fair bit of our time feeding and watering the current system, so that's one of the major drivers of doing something. So the NCTS2, the project we kicked off, we're actually partnered with an AWS Advanced Consulting partner via the digital marketplace. We've decided to go through with a AWS serverless approach, and most of that is really so that we can make more use of that shared responsibility model and really get some advantage out of that to reduce our operational costs and effort. But also that serverless approach shows that we reduce our hosting costs quite a lot, and at the moment it's not an operational system at the moment, but the testing all shows that's basically going to be about 10% of the current running costs, hosting costs that we have at the moment, which is obviously fairly significant. We're also been really careful to make sure that we're using all of the services that are in scope of the compliance program for AWS, and that keeps our IRAP assessment much simpler. We've got to go through an IRAP assessment and then obviously ongoing IRAP assessments, and at the moment that's a big pain point for us. As you saw probably on the previous slide, we're using Azure AD as the identity management, and we're actually moving that into Cognito. And then the whole code base for this and pipelines for deployment is actually moving into AWS and Code Commit, Code Pipeline, that suite of tools. So this is, again, a really rough, high-level overview. It's a little bit more complicated than this, and this may actually look more complex than the previous system, but in many ways it's actually not, mostly because it's using a bunch of AWS platform services rather than rolling our own versions and configuring all of our own web servers and API gateways and those sorts of things. So as a result, that causes it to be a lot simpler, but the key for us is actually how much simpler it is to deal with the ongoing security requirements and the feeding and watering of this system. So I guess the key features are really, it's all via CloudFront, using Lambda at Edge to do authentication and authorization. All the static content, protected and unprotected, is out of that bucket. And then ultimately an ALB sitting over the top of a bunch of services. These are the underlying services that weren't shown on the previous diagram. And ultimately still cloud formation and code pipeline. I guess we're probably keen for AWS to get that CDK into a production state to maybe deal with some of the cloud formation, which is still a bit complex. So what next for us? We're actually in the sort of final phases of testing and bringing this system live. We're re-engineering those operational procedures, but re-engineering you can sort of read as largely slashing and burning. There's really a lot less to do, and that's what we're aiming for. Penetration testing, IRAP assessment, again, much simpler than we previously had to do and much less ongoing effort. Clinical safety assessment, that's something that we always have to go through with our systems. Again, because the operational procedures can be made much simpler and they can be made traceable, it makes that assessment and those ongoing assessments quite a lot easier. And then ultimately migration and cutover to that system. And then we're on to more functionality, and hopefully that means that we'll have reduced ongoing costs and effort so that we can spend more of our time focusing on what we're good at. A bit like what we're trying to do for the vendors to make them provide these services so that they can focus more on what they're good at, which is their applications, and less time worrying about the intricacies of terminology. We can spend less time worrying about the intricacies of these systems and more time worrying about the terminology ourselves. So I guess the takeaway from this is the NCTs is there. It's there for people to use as a piece of national infrastructure to simplify terminology services. So if you're implementing terminology, please use it. If it doesn't meet your needs, we're very, very interested in hearing about that, because we're always trying to improve those services. And then ultimately, we started out implementing into AWS, into a cloud-based platform, but probably at the time, a number of years ago, were reticent to really commit to platform services to in one sense, to lock ourselves in to an AWS services so we couldn't sort of move those services later. But also a bunch of security concerns that the IRAP-based services now have really allayed. And as a result of that, we've incurred operating costs that have been higher than they otherwise might have been. And we're really now looking to try to leverage those platform services out of AWS so that we can reduce those ongoing costs. And it looks like it's going to shape up pretty well. So thank you. I think that's all I've really got for you. On the left there, there's some sort of contact details. On the right, there's some of our developer resources. Thanks.